Next up, I would like the lowest structure for the following ions. So I just need to note that if it's a negative charge, I need to add an equivalent number of electrons. It would make sense because if you have more electrons, so I've added electrons, that means that the electron to proton ratio is no longer 1:1. That means I have now more electrons, which means more negative charges than positive charges. So it goes from being neutral to negatively charged. And that would mean that a positive charge means the opposite, and it means that I need to subtract an equivalent number of electrons. And so just reverse the logic. If I have less electrons, that means I have more protons. I have less electrons because I've subtracted off electrons. And that means the ratio is no longer 1:1. I have more protons, more positive charge, and so the ion is positively charged. And so let's start with NH2 minus, when I count the valence electrons, I will have 5 from the nitrogen, 2 because of the 2 hydrogens, and then I'm going to add 1 electron because of this negative charge, which means I have 1 extra electron. And this is going to give me 8 electrons. I will choose nitrogen as my central atom. It can make the most bonds. And so now I've taken up 4 electrons. I can't place any of the extra electrons on the hydrogen, and so I'm going to place them on the nitrogen. Next up, I want to check my formal charges since all of the valence electrons have been taken care of. On the hydrogen, I have 1 valence electron minus the 1 electron it's donated to this bonding pair, and so it's going to be 0. On the nitrogen, I have 5 valence electrons minus the 4 electrons I have in lone pairs minus the 2 electrons I have 1 electron in each of these bonding pairs, and I have 2 of them. So this is going to give me 5 minus 6, and that's going to give me minus 1. This makes sense. I expected a net formal charge of minus 1 because the net formal charge should add up to the charge of whatever you're trying to draw out. And the formal charges have been minimized, valence electrons have all been taken care of. And so this is going to be the best structure. For the next one, I have H3O plus. My valence electrons are going to be 6 plus 3 into 1 because of the hydrogens minus 1. And so that becomes 6 plus 3 minus 1, and that is 8 electrons too in this case. So I choose oxygen as my central atom. It can make the most bonds. And I will now connect hydrogens to it, 3 of them. See if I have any remaining electrons. I have 2, 4, 6, so I do have 2 electrons left over to place on my oxygen. Next up, I check my formal charges. On each of the hydrogens, they have 1 valence electron and 1 electron inside of the bonding pair, yielding 0. And on oxygen, it is going to be 6 minus the 3 electrons it has in these bonding pairs, minus 2, giving me a positive 1. This is expected. I expected a net formal charge of positive 1, and that positive is on the oxygen. I've minimized my formal charges, the net adds up, and all of my valence electrons are taken care of. This is the best structure.